At this point, we're ready to start building our Quart counter application. So start the Docker client if you haven't already, and type the following on your terminal. Make sure you're on the counter application folder. Docker will start downloading the Postgres and Ubuntu images and set up your containers. Be patient, this might take a few minutes on the first run, but should be faster after that. When everything is done, you will get an error building the web container, which is expected, but your Docker client should show the database service up and running. We'll install some database packages we will need. The first is psychopg2 binary, a library that allows Python applications to connect to Postgres databases. We'll also install the databases package that allows async connection to databases. The third, as we mentioned earlier, is the SQL Alchemy library, but even though we'll install the whole package, we'll be using the core module for our application. So open the PyProject TOML file and then add the following on the Tool Poetry Dependencies section. We haven't initialized our local poetry environment, and we want to do that for two reasons. First, installing the poetry packages on the host machine allows our code editor to understand the packages and do linting, so that we can see issues as we write the code. Second, this will allow us to do a hybrid approach where we run the application on the host machine, but connect to the database on the Docker container, which allows us to run the application as well as tests without having to rebuild the web Docker container. For example, in my Visual Studio Code editor, I can have tests run from the UI or start-stop the application with one button. I have added the VS Code configuration on the repository if you want to add it to your folder by heading over to this URL. Once the code is good to go, you can rebuild the web app container and run the whole stack from Docker. So stop the Docker Compose with Ctrl+C and go ahead and install all the poetry packages by doing poetry install. Once that's done, we'll go ahead and create our database driver file. So go ahead and create a new file we'll call dbpy. First, we will import the database class from the databases packages, which gives us a synchronous connection to our Postgres instance. We'll also need to import the current app from Quart. Think of the current app as the currently running instance of the Quart application. We'll need it to read the settings that we've set for the database connection. Finally, we will import the SQL Alchemy package to define an application-wide metadata object that will track all the models in our application, which will allow us to manage migrations when we start using Alembic. Next, let's create the database connection using the user, password, host, and database from those settings. Finally, we acquire the connection and return it to the caller. Save the file. Now let's go ahead and create our first and only blueprint of the application, the counter module. First, create the counter folder and inside create the empty initpy to declare it a module. Then create the models.py file with the following contents. We'll begin by importing some modules from SQL Alchemy. The names might sound familiar. Table allows us to set up a table in the database. Column allows us to create the table columns, and integer, which is the only column type we use. We also import our metadata object, which will allow us to do introspection about the table schema when we use migrations. You need this object in any model you create. Then we define our counter table as a table consisting of two columns: our ID, which will be the primary key, and count, which will hold the current counter of the application. Notice we define the table name as counter and add the metadata object as part of the definition. Save the file. Now let's go ahead and build the views.py file, which will be our main controller and blueprint. We'll import blueprint to create the counterapp blueprint as well as the current app, which we'll need to get the database connection. We'll also import our counter table from our model file. So let's define the blueprint itself, counterapp. The only route this controller has is the root /, which we'll call the init function. We begin by fetching our database connection from the current app dbc. Next, we build a query which will select all the records in the counter table. In this application, it will always be just one record, as you'll see below. We'll get more familiar with the select function from SQL Alchemy, but for now just think of it as doing a select star from counter table. We then feed the result of the query to the result variable, but notice the use of the await keyword there. Indeed, the connection execution is an asynchronous operation that will resolve into a coroutine which will eventually return the data we need. We'll also set an internal variable of count to none. We then get to the main forking point of the script. If we don't get any results from the query, it means it's the first time we're running the application. So we'll build an insert statement, setting the value of the count column to 1. We'll then await the insert statement and store the results in the result variable, and finally commit it to the database, again using an await operation. Since this is the first time we run the application, we can safely say that the count variable is 1. Now on the else statement, if we do get a result from the select query, we will fetch the first row of the result. We then add 1 to the contents of the count column and store it in the local count variable. We then build an update statement with the value of the local count variable, execute it, and commit it. Finally, we return the value of the count variable to the request as HTML content. As you can already notice, any database connection operations must be awaited, since they are I/O operations that can yield to the event loop. Save the file. Next, we'll create the application factory as we've done in the past in my Flask course. Call this file application.py. We begin by importing port and the DB connection variable from the DB file we created earlier. Next, we define the factory variable as createApp with a config overrides parameter that will allow our test to change the settings environment variables when running them. We then begin by creating an app instance of Court and configure the app from the settings.py file contents. Then update the app with any changes passed on the config overrides parameter. After that, we import the counterapp blueprint from the views.py file and register it. We now need a way for the application to open a reusable connection to the MySQL database server. For that, we'll use a couple of special decorators called before serving and after serving. These decorators set up functions to be executed the first time the application is started and right before the application will be closed, which allows us to open the connection once and keep it open for all requests, without needing to close and open it on a per request basis. For the before serving function, we'll await a database connection. We then store this connection in a context variable called dbc that will be available anywhere you call the current app in any view or model. Finally, with the after serving function, we'll close the database connection properly so any pending database requests are taken care of. Save the file. We're almost done with the core application. We just need to create the bootstrap file that will spawn an instance of the application factory. We'll call this file manage.py. This is a simple file. We just need to import the createApp function and then execute it and store it in a variable called app. Save the file and let's go ahead and start with the database migration configuration.